For the pendulum, as you can see in the sheet that I posted, where the equation we're actually dealing with in the lab is the acceleration due to gravity is 4 pi squared divided by t squared times length of the pendulum. For the error, we're going to come up with 2 times the percentage error for, or the decimal in this case, for the period of the pendulum, and there's a 2 in front of that because it says t squared. You can also algebraically look at that you say, well, in the denominator I divide by t times t, and then you have the same thing twice, but of course it does appear twice in the equation. And of course then we add to that the error in the length. So let me use my example. So I came up with that I measured 28.4 seconds, and I have an error of 0.2 seconds in my measurement, which is my reaction time. That's where I got that from. And so then I divide each of these numbers by 20 because I measured for 20 swings, and I have a length of exactly 50 centimeters. That's what I tried to measure, plus minus 1 centimeter is my error. Notice that this is in the neighborhood of about 2%. We'll see that in a moment. And this one is in the neighborhood of a little bit less than 1%. Okay, so let's calculate these here. Delta t over t, so that's 0.01 divided by 1.42, which is 0.007. That's 0.7%. That's what I said a moment ago. And 1 divided by 50, which of course is 0.02. And that's also what I said a moment ago, about 2%. Then we're going to add them according to error propagation. So it's square root of parentheses, and then again parentheses, 2 times 0.007, close the parentheses, square, plus 0.02 squared, close the parentheses for the square root, and I come up with 0.024, or 2.4% is my error. And when I actually calculate g with the original equation, 4 pi squared, or I should say that 4 pi squared doesn't figure into the error propagation because there is no error attached to pi or to 4. So 4 pi squared divided by, that was 1.42 squared times 50 centimeters, and I come up with 979 centimeters per second squared. And then I multiply that with the error I just calculated, 0.0244, and I come up with a rounded 24, so my result is 979 centimeters per second squared, plus minus 24 centimeters per second squared, which covers the actual result of 982 centimeters per second squared in Alaska pretty well. Looks like the error is pretty large, but notice that for a length of just 50 centimeters and an error here of 1 centimeter in the length of the pendulum, that's a 2% error, which out of 982 is about 20 centimeters per second squared error. That error actually goes down the longer the length is. So if, for example, here I'm going to take 200 centimeters, then my length is 4 times as long. My error over here might stay at 1 centimeter, but my percentage error goes down by a factor 4 because I quadrupled the pendulum length, and then that final error here might go down to about a quarter of what it is now. So for a longer pendulum, we would have a better result and a smaller error as well.